All right, this is problem number 43 in chapter 9. Problem 43. In this case, we have an elevator. This is our elevator, and it's accelerating upward at 1 meter per second squared. Okay, starting from rest. What we want to figure out is how much work is done by gravity. Well, we are given also that it moves 10 meters in a direction going this way. Okay, so for gravity, the work done by gravity is just the mass times g, the force of gravity, times the distance, times the cosine of the angle. But in this case, the cosine of the angle, it's moving up, but gravity's going down. So the cosine of the angle, or the angle, is 180 degrees between here and here. So cosine of 180 is just -1. So the work done by gravity is going to be 1,000 times 9.8 times 10 times -1, which is the cosine of 180. So we get that the work done by gravity is just equal to minus 98,000 joules. Okay. Now the work done by the tension, well, we have to figure out what the tension in the elevator is first. So we're going to do our free body diagram. We have mg here. We have tension here. So this is part A. In part B, we're going to do F net y is going to be equal to T minus mg. But we do know that this is accelerating, so that ma is equal to T minus mg, and the tension is going to be equal to mg plus ma. And so we're going to say, oh, the tension is equal to, we can factor out the m, 1,000 times 9.8 plus 1, because that's the acceleration that was given to us. And so we get the tension in the cable is equal to 10,800 newtons. Okay, but the work done by the tension is the force, T, times the distance times the cosine of the angle. So the work done by tension is equal to 10,800 times the distance, which is 10 meters. Now we got to figure out the angle. Well, we're moving this way. The tension's also the same direction, so the cosine of theta is 0. The cosine of 0 is equal to 1. So the work done by tension is just 10800 joules, or 108,000 joules. All right. Now there's several ways to do part C, so this is part B, the answer here. But the easiest way is to use what we know about work. We know that work is equal to the change in kinetic energy, which is equal to kinetic energy final minus kinetic energy initial. All right, and this is net work, so the total amount of work. Well, we know the initial kinetic energy was 0 because the velocity was starting from rest, so there was no velocity there. So to find the kinetic energy, which is what they want to find, we just have to know what the net work is. Well, since those are the only two forces acting on it, those are the only amount of work done, we can just sum those. And we say, oh, 108,000 minus 98,000 leaves the kinetic energy final of 10,000 joules. Okay. But I want to add one more thing to this. Let's figure out how fast it's going at the end of that time. Now we could use our kinematic equations because we know its acceleration, we know how far it went. Or we can just use the fact that we know what kinetic energy is and we know what the amount is. We can say that, oh, well, 1/2 mv squared is equal to 10,000. Or we can say v is equal to the square root of 2 times 10,000 divided by the mass, which is 1,000. Well, this is really easy because 10,000 divided by 1,000 is 10, so it's the square root of 20. Square root of 20 is 4.47 meters per second. And so there's more than one way to do this, but this is an easy way to do it. And when you get used to working energy, you'll find it's one of the easier ways. In fact, energy is almost always an easier way to do things than to use the kinematic equations. That's the answer to number 43.